Every few quarters, the technology landscape shifts and new terminology emerges to describe evolving concepts. Just as we've moved from talking about big data and IoT to digital twin and digital thread in recent years, we're now witnessing another transformation with Agentic AI taking center stage. But what does this mean for product lifecycle management, PLM, and how might it fundamentally change the way organizations approach their product development ecosystems? The timing couldn't be more relevant. Just 2 weeks ago, Dassault Systems revealed their 3D University Plus initiative and related AI-based services, signaling a major strategic shift toward AI-augmented product development. Even more recently, Propel launched their Propel One suite, an agentic AI platform powered by Agentforce aimed at transforming product value chains. These announcements from industry leaders confirm what many have suspected: we're at the beginning of a paradigm shift in how PLM systems will operate. Key terms and definitions. Before diving deeper, let's establish some key terminology that will help frame our discussion. Agentic AI, AI systems designed to act independently on behalf of users to accomplish specific goals. Unlike passive AI tools that simply respond to queries, agentic AI can perceive its environment, make decisions, and take autonomous actions. Microservices, an architectural approach where applications are built as a collection of small, independent services that communicate through well-defined APIs. Each service focuses on a single business capability and can be developed, deployed, and scaled independently. Digital thread, a communication framework that allows a connected data flow and integrated view of an asset's data throughout its lifecycle across traditionally siloed functional perspectives. Digital twin, a virtual representation of a physical product or process that serves as the real-time digital counterpart of a physical object or process. The evolution of PLM architecture. The journey of PLM technology has been one of continual evolution. From the early days of the 1990s with basic 3D CAD systems like CATIA, Pro/Engineer, and Unigraphics running on Unix workstations, to the subsequent birth of product data management, PDM, systems needed to handle the explosion of engineering files, the industry has constantly adapted to new challenges. As enterprises needed to manage not just the files but the entire product lifecycle, including BOMs, change management, supplier relationships, and ERP connections, the modern PLM system emerged. Through a series of acquisitions and technological advances, the big players consolidated their offerings into increasingly comprehensive but monolithic platforms. What we've witnessed over the past 2 decades is a trend toward ever-increasing integration and consolidation, with PLM vendors striving to create all-encompassing platforms that manage every aspect of the product lifecycle. While this approach has succeeded in bringing more business processes under the PLM umbrella, it has also created systems that are increasingly difficult to customize, integrate, and adapt to changing business needs. The traditional PLM architecture reflects the technology constraints of its era, an era before cloud computing, microservices, and modern APIs had become mainstream. Today, however, we're at a fascinating crossroads where these technologies are converging to create new possibilities. Configurable web services, the foundation for a new approach. One of the most promising developments in modern PLM architecture is the emergence of OData access to PLM data. Unlike the rigid, predefined integrations of traditional systems, approaches such as configurable web services from Aris Innovator provide a flexible foundation for exposing PLM data and functionality as discrete, reusable services. The concept is elegantly simple yet powerful. Rather than forcing all systems to conform to a single data model or interface, CWS allows organizations to expose precisely the PLM data and functionality needed for specific business processes. This approach creates building blocks that can be assembled and reassembled as business needs evolve. What makes this approach particularly powerful is its compatibility with low-code development platforms. Instead of requiring deep programming expertise for every integration, low-code platforms enable business analysts and process experts to create connections between systems visually. This democratization of integration capability accelerates innovation and reduces the technical debt that has plagued traditional PLM implementations. For example, a change management process that spans CRM, capturing customer feedback, PLM, implementing design changes, and ERP, updating manufacturing plans, can be orchestrated as a workflow of discrete services rather than forcing all the data through a single monolithic system. This preserves the specialized capabilities of each system while enabling seamless business processes across organizational boundaries. Eris CWS stands out in this regard. Announced in 2024, CWS provides ease of access to PLM objects in Eris Innovator, allowing users to create low-code web services that can be integrated with other systems, such as CRM and ERP using tools like N8N. This feature is not entirely unique, as Windchill has had OData access for some time, and 3D Experience data can be accessed via their iPus. However, Eris' approach is more user-friendly and flexible, making it an excellent choice for organizations looking to adopt Agentic AI. AI agents as orchestrators. This is where Agentic AI enters the picture, transforming PLM from a centralized system to an intelligent ecosystem. An AI agent is fundamentally different from traditional automation in that it can perceive its environment, make decisions, and take actions to achieve specific goals. Rather than simply executing predefined workflows, agents can adapt to new information and circumstances. Propel's recent launch of Propel 1 demonstrates this new approach in action. Their Agentic AI suite, powered by Agentforce, aims to transform the product value chain by enabling agents to orchestrate processes across traditionally siloed systems. Similarly, Dassault Systèmes 3D University Plus's initiative signals their recognition that the future of PLM lies in intelligent agents operating within virtual spaces. In the context of PLM, AI agents can serve as orchestrators that coordinate activities across a network of microservices. For example, a change impact agent might analyze a proposed design change, identify affected components, assess manufacturing implications, and notify relevant stakeholders, all by interacting with various PLM microservices. A supplier recommendation agent could continuously monitor performance data, market conditions, and design requirements to suggest optimal sourcing strategies. A design optimization agent might work in the background, running simulations and suggesting improvements based on predefined criteria while engineers focus on innovation. The key insight is that these agents don't replace existing PLM systems, they augment them by providing an intelligent layer that can coordinate across systems, learn from patterns, and make recommendations based on broader context than any single system possesses. Practical implementation can start simply. Workflow automation tools like N8N offer a gateway to this approach, allowing organizations to create workflows that connect to PLM data via configurable web services. While these initial implementations may not have the full intelligence of autonomous agents, they establish the architectural foundation upon which more sophisticated capabilities can be built. Creating a robust real-time digital thread. Perhaps the most exciting potential of Agentic AI in PLM lies in its ability to finally deliver on the promise of the digital thread. Traditional approaches to digital thread have struggled with the inherent complexity of maintaining consistency across diverse systems and processes. No single vendor platform, regardless of breadth, has fully solved this challenge. AI agents offer a new approach. Instead of forcing all data into a single repository or model, agents can maintain the relationships between data across systems. They become the guardians of digital continuity, ensuring that changes propagate appropriately while respecting the specialized capabilities of each system. For manufacturing organizations, this could mean dramatically reduced time to market as changes flow seamlessly across systems. Enhanced quality as potential issues are identified earlier in the development process. Improved collaboration as stakeholders work with a consistent view of product information. Greater agility as the PLM ecosystem can evolve one microservice at a time. A vision for the agentic PLM future. Imagine a product development environment where engineers interact with AI agents as naturally as they do with human colleagues. An engineer might ask, what would be the cost impact if we switch this component to aluminum, and receive not just an answer, but the context and reasoning behind it, drawing from pricing data in the ERP system, performance simulations in CAE tools, and manufacturing constraints in the MES system. This vision isn't science fiction, it's the logical evolution of the trends we're already seeing with announcements like 3D University Plus's and Propel 1. The building blocks are falling into place: flexible microservices-based architectures, low-code integration platforms, and increasingly capable AI systems. As with any technological transition, the journey will be evolutionary rather than revolutionary. Organizations will start with specific high-value use cases, gradually expanding the scope and sophistication of their AI agents. The key is to begin with an architectural approach that enables this evolution, one based on microservices, APIs, and flexible integration. In our next article, we'll explore more deeply how AI agents can maintain digital continuity across systems, with practical examples of how organizations are implementing these concepts today. We'll also examine how this approach enables more powerful AR/VR digital twins that draw from real-time data across the enterprise. The PLM world has always evolved by building on previous innovations. Just as CAD led to PDM and then to PLM, we're now seeing the emergence of a new paradigm, one where AI agents orchestrate a flexible ecosystem of specialized services. The result will be systems that are both more powerful and more adaptable than anything we've seen before. What steps is your organization taking toward this new paradigm? Are you exploring how AI agents might transform your product development processes? I'd love to hear your thoughts and experiences in the comments. Feel free to provide feedback or let me know if there are any specific points you'd like to emphasize or adjust. Once you're happy with this draft, we can move on to the next articles in the series. More reading. https://www.linkedin.com/post/demystifying-eras-zen-art-poem-customization-finicaro. https://www.linkedin.com/posts/finocchiaro/eras Connect Paris 2024 Finos Field Report Activity 7252344017194041345 GBPJ/ https://eras.com/and/blog/working-and-collaborating-seamlessly-with-digital-threads https://eras.com/and/blog/enabling-bidirectional-traceability-with-digital-threads-safeguarding-quality-and-compliance https://eras.com/and/blog/connecting-siloed-data-models-with-digital-threads-the-unified-product-development https://eras.com/exposing-data-context-enhancing-decision-making-with-digital-threads. Finos articles about Agentic AI in PLM. Part 1, The Agentic AI Revolution, Reimagining PLM as a Flexible Microservices Ecosystem. https://www.linkedin.com/post/agentic-ai-revolution-reimagining-pom-flexible-michael-finicaro-wq. Part 2, Bridging the Gap, Making Agentic AI Practical in Today's PLM Reality. https://www.linkedin.com/post/bridging-gap-making-agentic-ai-practical-today's-pom-finicaro-ibtlu. Part 3, Future Horizons, Model Context Protocol, MCP, and Autonomous Systems in Manufacturing PLM. https://www.linkedin.com/pulse/future-horizons-multi-agent-cognitive-platforms-pom-finicaro-www.ce. Part 4, Transforming Engineering Workflows, Agentic AI and MCPs Address Daily PLM Challenges. https://www.linkedin.com/pulse/transforming-engineering-workflows-agentic-ai-mcps-pom-finicaro-y3tfe. Part 5, The Bill of Information, Beyond Bill of Materials in the Digital Thread Era. https://www.linkedin.com/pulse/bill-information-beyond-materials-digital-thread-era-finicaro-qvlsc.